Hello and welcome. Thanks for joining me for a discussion about how open source software is used at the network edge, how companies and ourselves use data center infrastructure management tools to orchestrate both their infrastructure and the configuration of their service across multiple providers and multiple data centers around the globe. My name is Craig Jackson, and I work for a company called NetActuate. When I'm not working, I'm typically a redneck adventurer trying to climb mountains in these off-road machines. And if I'm not outside in the woods, then I'm trying to learn music by playing with the synthesizer, pushing buttons and twisting knobs. Process and automation has always been a part of my life. I was a surgical consultant, consulting and recommending surgical procedures to minimize waste and increase efficiency. I studied horticulture in college, and I do like to grow plants, but my true passion in life is the internet and internet service providers. And I found IRC in my teens, and I haven't left it yet. But when I am at work, I'm a DevOps engineer at NetActuate, and NetActuate is a global edge infrastructure and network service provider. We manage a global cloud compute platform that's spread out over 40 to 45 points of presence around the world. And we manage an Anycast network that's focused on low latency delivery of service to the end user. The HRoot DNS server is on our Anycast network. And we also offer DevOps consulting, and this is where I come in and help customers onboard onto our service. I'm typically involved in helping stand up initial infrastructure and facilitating their needs, and occasionally I get to be a part of their design or service testing to make sure that they're getting deliverability across the globe. One of my favorite things to do, and something we pride ourselves on, is helping companies turn monolithic services into global architecture. Before we get too deep into the talk, what we're going to start with is philosophies of abstractions, and we're going to define some terms. Source of truth, for example. We're going to use data center infrastructure management tools, DCIM, as a source of truth. And when we can trust this truth, it allows us to orchestrate not only infrastructure, but service configuration, which allows room for a Terraform module. We're going to get into how to orchestrate both into and out of your source of truth, and wrap it up with some DevOps philosophies to end. But first, let's come to terms. I've already said DCIM several times, and ultimately, data center infrastructure tools just hold the data and provide different organizational views into your infrastructure. We're also going to be talking about infrastructure as code. I'll primarily live in the declarative state where we describe what we want and hand over that description to an orchestration tool which takes care of our key value pairs and builds what we want for us. There is also imperative infrastructure, which is script driven. It's like a recipe that Chef, an orchestration system, uses. Ansible is ultimately just a series of Python commands or API calls in order to configure a service. And it still beats a web interface, but it is just a checklist approach. We're also going to talk about chaos and order. And what I want you to understand about these two terms is chaos is not good and order is not good. Neither are they bad. These are both just states of being. Too much order is monotonous, boring, repetitive, and bland. Too much chaos is, well, chaotic. Every day that you wake up, you start your day in a state of chaos. Where am I? Who am I? Where am I going? What time is it? What do I need to accomplish today? As soon as you wake up, you begin to reconcile that system. But chaos is where your intent and reality are separated. Systems are unpredictable. The configuration and the data is spread out over multiple systems and people. And what this means is that all of the changes that you make to your service or your product is ultimately manual. You have to control by doing. But the way that you calm a chaotic state is by providing order. And the way to always provide order to chaos, in my opinion, is through continuous reconciliation. If you abstract the problem and you build the systems around it, then the system knows what it should be, and it works to make it so. The state is declarative, observable, and self-healing. And because of that, you're more describing and expressing intent and trusting the systems and the engineers behind you. And so with all of this chaos and order, why do we create anything at all? To start from nothing and go into something, it's chaos and it's scary and it's uncomfortable to change. So why do we do it and how? And I think we must start with the ancients. One of the first abstractions that we humans built upon was the sun and seasons. And we invented time. And that allowed us to start to gather together and accomplish goals in a cohesive manner. We can help each other and protect each other. And then with time, we can abstract again and build a calendar. And now we can plan into the future. Farming, agriculture, industry, all of this was built upon an initial good abstraction. But the only way that they could build that abstraction and have it persist over time and work for them was because they had a source of truth. The sun rises at the same time every day for pretty much everybody. We know when we're going to start our day. And because of that, we can gather and build together. And these abstractions we haven't had to touch in a very long time. The calendar has worked for humanity for a very long time. And it all comes down to the initial abstractions. But when you look at time and you look at the seasons, you realize that it is just a continual loop. Some build, some destroy, but they all build upon each other and maintain a state. And so it's these reconciliation loops that I think is how we create reliable systems that are distributed across many different data centers. And we can maintain the state of both the network, the service, and the infrastructure through reconciliation loops. And the way that we build these loops and the way that we define infrastructure introduces infrastructure as code. Because what we can do with a source of truth is start building abstract systems around it that keep our intent as close to reality as possible. We're always trying to balance chaos and order. And DevOps and building services, especially on a global level, is quite chaotic. There's so many options to get started. And I think you should have all of them. The problem with all of them is data duplication. Somebody has to add all of the data that we already have to the new service. And if you do that later, it becomes difficult to integrate with consistent information, unless we start with the Holy Trinity. And I think these three tools can provide the most comfort and give you the most order to that chaotic system that we just saw before. And so I introduced NetBox, which is the DCIM tool that we're going to talk about and use today. NetBox is a source of truth, if you make it so. but it's just a data center view of your infrastructure that's spread out over multiple providers. Today, we're going to build a Terraform module that populates NetBox after it builds the infrastructure. Terraform and OpenTofu, the open source counterpart, are orchestration loops in and of themselves. You define a state, you press enter, and it builds it. And you can automate so that every time it runs at a certain schedule, it maintains that all of your infrastructure that you want is available and running. When you have all of that data into NetBox consistently and you can trust it, we can then begin to orchestrate out of it. And we can begin to configure all of the remote services and open source tools that you're going to use to prototype a service or scale it globally. With these three tools, you get infrastructure, you get truth, consistency, and maintained configurations. So we'll start with NetBox. And again, this is originally designed just to view infrastructure that's spread out over multiple data centers, clouds, or providers. It gives you organizational hierarchy. In every different operational context gets a different view. You can view your network topology and network devices for that team. You can begin to make device relationships between physical and virtual components. And you can break out your infrastructure into multiple device groupings, which allows you to have targeted views depending on who needs the data. But it can be more than just a view. It can be a source of truth. And I would recommend staying away from human entry. There are two ways to use NetBox as a source of truth. Today we're going to build a Terraform module that populates NetBox, and then we're going to orchestrate configurations out of NetBox using Ansible. But with the appropriate Ansible provider, you could use NetBox as the orchestration tool for infrastructure as well. You type into the NetBox interface the systems you want, and because Ansible can pull that inventory dynamically and have it always be slightly different, then it can build the services and the infrastructure you need out of your NetBox entry. So there's two ways to do this, and today we're going to talk about Terraform. So Terraform built a wonderful orchestration loop that builds infrastructure and maintains infrastructure state. It is a good state machine for infrastructure. You pull out basically all of the API or portal pieces that you need to create a machine, and you simplify it into a text file. And it really is this simple. You have a resource name of a specific type. You name that resource. You put it in a location, and you tell the service how big you want it to be. And this becomes copy and pastable for multiple machines. And this begins declarative infrastructure. But ultimately, it can be organized chaos. Because if ultimately with these abstract systems, if you touch it twice, you've failed to plan once. And I got really excited when I got introduced to Terraform for the first time, because I no longer wanted to ever live in a portal again. I list my provider, in this case it's NetActuate. I load a key into their system, and I can use that key to build servers that I can log into. And this approach worked. But when a customer comes to me and wants 45 machines, this is still a lot of manual entry, manual editing, and there isn't any abstractions here. It doesn't scale well. And so then I found for each. And we went from static definitions to dynamic. I've abstracted a little bit more in what a server is, and I've reduced the amount of human entry that I need to do to add a server. Now, to add a server, I have to copy and edit one line. But the problem with for each is that you wind up creating nested dependencies, and they can be hard to track. And so I do have a resource map of several servers, in this case 3. But a lot of our customers want to build BGP sessions or add network components as well. And a BGP session might only live on one of these servers. And that becomes completely possible, but it becomes another layer of editing. It's future work. And we can avoid this with one more layer of abstraction. I would promote that the original static definition, is still the better way to do it, because you can see instantly what your infrastructure is. This method, using for each, it's much more difficult to know exactly what's going on here. And so the way that we can build memory that lasts like time or the calendar in our company is by abstracting what we're doing, not server by server, but by POP. My customers aren't building servers. I'm building servers for them. And so this method works for me to stand up one server in all of our points of presence for that customer. But the customer's not managing one server per POP. They're managing POPs. And this is just a point of presence. It's an announcement of your service in another region that attracts customers to your service. And when we abstract what we're working on to this level, it becomes easier to manage later. It's more abstract early, it's difficult to process, it's just keys and values. But when you do this part correctly, and this is planned well, the future gets a lot easier. And the engineering teams that interact with each other, it's much calmer and easier to work with each other because everything is laid out, and now whole modules become copy and pastable. And so we're no longer copying servers and creating more servers. We can duplicate POPs. We can build the same service configurations into multiple different providers or data centers. And so now that we're managing a POP, we get to reuse and build modules for every single point of presence. And so in this case, we have NetActuate for the infrastructure, and we're going to load that infrastructure into NetBox. And so I have those two modules loaded. A Terraform module, if you haven't worked with one before, is exactly the same files that you interact with in Terraform normally. You're just breaking it out into a hierarchical structure that you can follow and edit later. And so modules turn early chaos into future order. If you build the module correctly and you map the abstractions well, then scaling your service goes from copy and pasting 100 times to just adding one more line. When I bring up a new region, I can define how many worker counts I want. And worker count is not provided in the Terraform provider. We've abstracted that into the module and told Terraform that when it sees this to repeat the same process and duplicate it. This is an orchestration loop. This is ultimately what Kubernetes and Rook and distributed systems use frequently. The Grafana suite also does this. You define workers, you define POPs, and you let the systems around it create the state that you intended. Now that we have a Terraform module, we can combine Netbox and NetActuate. And this automates POP registration in your source of truth. This allows for you to trust every member in your company to orchestrate out of the source of truth and configure services across your infrastructure. And the way that we configure services is through Netbox dynamic inventories and Ansible. And when you load this into AWX, you now have another orchestration loop system that takes the configurations and the values of your infrastructure from Netbox and loads it into all of the remote machines around the globe in multiple providers and data centers. And what this is lovingly called is the Terrible Stack. And it's Terraform into Ansible. It's real-time orchestration of POPs. We're building entire infrastructure, and as soon as it's built, we're configuring it across the globe to announce our service, all automated, easily edited, with minimal human entry. And when you have a module and you have your service and it's spread out all across the globe, it becomes a little bit easier to just add more services to each POP. And you begin to realize that a lot of systems integrate. You can configure through Terraform, and then you can load in specific values from Netbox to fully configure the service or the ancillary monitoring for your product just through automation scripts. And so when your boss comes to you in a month and wants to add a bunch of features, you don't have to go back and edit everything. You can just add, because all of the data is already loaded into the source of truth, and it becomes much easier to configure alerting, monitoring, observability, and everything else. And so to get back into just the DevOps philosophies of this, a military phrase that works well here is slow is smooth, but smooth is fast. If you slow down and you abstract the situation early and you put together a well-formed plan, then the future gets easier and growth becomes smooth, and smooth is fast. And if you did the abstractions well and you built the modules well, then you don't have to go back and continually edit to add. It becomes much easier to scale your service. But we have to protect our source of truth. And so I would really promote not logging in to machines anymore. In the past, to fix a problem, you would have to log into the machine, go into log files, figure out what was going on. But we're just not going to log in anymore. If that server fails for any reason, hardware or a bad configuration due to a network problem, the nice thing is you can build the orchestration loop to just nuke the machine and completely reconfigure it, because it's all automated and the source of truth is trustable. So don't touch it twice, don't configure manually, and don't log in anymore. You have to trust your systems. So what does this philosophy enable? If you maintain a source of truth, you get consistency, reliability, observability, and comfort, ultimately. If you automate configurations, we can then begin to abstract role-based access controls. Every single system has different values that they want and different naming conventions for a role. But you can abstract that in your company early and apply the same company role to different system roles as you see fit. You can begin to abstract your access, which allows you to hire more effectively for specific smaller roles. You can begin to hire data entry specialists instead of engineers to manage your infrastructure. And if it's all automated, then you can scale quickly and you can react quickly. And the nice thing is it's declared. It's all in a configuration file. And so it's version controlled and you can roll back your infrastructure. And when adding a new feature or adding monitoring becomes a minimal module to build, you begin to enjoy the fruits of your labor. You're no longer just chasing project to project. And so in closing, these orchestration loops allow you to flow easily because you declare, you build, it's confirmed, and you know it's true.